Okay, Algebra 1, here are a few examples on how to multiply monomials by monomials and then binomials by binomials. And then you have one where you're going to have a monomial raised to a power. So let's look at this first example up here, 3a squared times 2a to the third. You always multiply the coefficients, so we're going to do 3 times 2, that equals 6. And then to multiply the powers, you would add the exponents. So we're going to add 2 plus 3 to get a to the fifth. Because remember, a squared means a times a to the third means a times a times a. So to multiply these two things together, that would just give us 5a's, a to the fifth. And so this is the answer. Looking at the next one, we're going to be using distributive property. So we're going to multiply the 6a to the fourth times this, and then the negative 6a to the fourth times this. So there's no coefficient on this one. Well, there is. It's just understood to be a 1, so we still have negative 6. A to the fourth times a would be a to the fifth, and then that b just comes along for the ride since there's not a b over here. And now we'll multiply negative 6, a to the fourth times the 2a to the third. So negative 6 times positive 2 becomes negative 12, so I'll put that there. And then a to the fourth times a to the third, we're going to add our exponents, so that becomes a to the seventh. And then since we have no like terms, this is your answer right there. Okay, looking at this last one, whenever we raise a monomial to a power, this exponent out here doesn't have its own letter. It's an all-powerful exponent because it gets to multiply, sorry, I'll fix that. It gets to multiply everything inside to that power. So what that means is 3 to the third, a squared to the third, and b to the third to the third. So 3 to the third means 3 times 3 times 3. So that gives us 27. A squared to the third means we have a squared times a squared times a squared. And remember, when we do that, that gives us it gives us 6 here. And the way we can get that is just to multiply. You can always multiply exponents when it's an all-powerful exponent. So 3 times 2 is 6. And then b to the third becomes b to the ninth because we can multiply this one. So remember, you add when they are like these first ones where each of the exponents has the base. But if it's an all-powerful exponent, that's when you multiply the exponents. Just remember, you never multiply an exponent times a coefficient. You take that exponent tells the coefficient how many times to multiply by itself. And so this answer would be 27a to the 6th, b to the ninth. And I'm going to go ahead and do one more example that will have a fraction, since I know you had a fraction there on that last one. So we'll say negative 1/2a, and then I'll put in parentheses negative 4a squared, and then let's just say plus 6a to the third. Okay, so negative 1/2a times negative 4a squared means we're going to be doing negative 1/2 times negative 4, because you always just multiply the coefficients. Cancel out my 2's, so that leaves a 1 and a 2. And negative 1 times negative 2 would just give us a 2. So negative 1/2 times negative 4 is a positive 2, and then we multiply the variables. A times a squared would become a to the third. And then on your second one, you're going to multiply negative 1/2 times 6. We'll put that 6 over 1, cancel, make that a 1, make that a 3. So negative 1 times 3 becomes negative 3. So negative 1/2 times positive 6 is negative 3. Then we multiply the exponents. A times a to the third becomes a to the fourth. So on those fraction ones, all you have to do is just multiply the fraction coefficient times the coefficients on the inside, just like you were doing normal fractions. Put the whole numbers over 1, cross cancel, and there you go. So this answer is 2a to the third minus 3a to the fourth, and the coefficient or the variables again are not the same, so you can't combine these like terms. That's it. So I hope that's helpful, and I'll see you guys tomorrow, most likely. Bye.